Hey everybody, Mr. Mack here. Today we're going to look at the second part of quadratic equations. And in this section we're going to look at solving quadratics by using the square root property. We're going to solve by completing the square. And we're going to solve equations by using the quadratic formula. And we'll also take a look at what the discriminant is of the quadratic formula and how that helps us determine the number and the type of solutions. So let's take a look at the square root property first. We have, whenever we have an x squared term only and we have no linear x term in our equation, we can isolate the x squared term and take the square root of both sides. Notice we'll end up getting a positive and negative number for that solution because we get two solutions often for quadratics. So let's take an example here, x squared equals 8. We're going to take the square root of both sides because square root is the inverse operation of squaring. And that's going to give us x equals, so I'll just write this out. This is going to be plus or minus square root of 8. And what is the square root of 8? Well, we can use our radical properties of multiplication. And we know that 4 times 2 is 8, so root 4 times root 2 is root 8, and the square root of 4 is 2. Now, if you weren't sure how to come up with those factors here, we can always just make a prime factorization tree. And we start with 8, and then on the left we try to find our prime number, so I know 2 goes into 8 4 times, and then 4 is 2 and 2, and I can circle my pairs and put a box around my solo number. And so that means a pair of 2's would, if I have 2 times 2, that's 2 squared, and a square root of 2 squared would just be 2. So that maybe this helps you see, the 2 comes out, and then this 2 stays under the radical because it's not a pair. Okay, let's do another one of these, but we just have a little bit more work. So we haven't isolated the x squared term, so that's going to be our first step here, is to isolate this x squared. So let's subtract 1 to both sides first, and we get 4x squared equals 6. And then, so we have to undo the multiply 4 here, so let's divide 4. So now I get x squared equals, so a 6/4, a 2 is a common factor, so that would simplify to 3/2. And then now it's time to undo the squaring here, so we're going to take the square root of both sides, and that gives me plus or minus the square root of 3/2. Now we don't like having a radical in the denominator, so I'm going to rationalize that. We did this in a previous unit, so let's break this up here. So I have plus or minus root 3 divided by root 2, quotient rule of radicals, okay? And now what do we do to get rid of the radical in the denominator? We multiply top and bottom by root 2, and this will give us plus or minus root 6 over 2. The root 2 times root 2 is root 4, and the square root of 4 is 2. And this is our final answer right here. Okay, so let's take a look at example 8. Solve a quadratic by completing the square. Before we do that, we need to understand the standard form of an equation for a quadratic, and it's in this form right here, ax squared plus bx plus c equals 0, where a is not equal to 0. I mean, if a were 0 here, it would cancel this leading term, and this wouldn't be a quadratic, it'd be linear. So here we have our leading coefficient is a, and then b is the coefficient on our x term. C right here, that is our constant term, and it's set equal to 0. So we're given an equation x squared plus 8x plus 15 equals 0, and I have the steps right here for completing the square. First, move the constant term to the right side of the equal sign. So we're going to subtract the constant term, 15, and put it on the other side. So now we have x squared plus 8x equals negative 15. Okay, so then we're going to take half of the b term and square it. All right, so I'm going to take, our b term is 8, so I'm going to take half of 8, so I'm going to take 8 divided by 2, and then I'm going to square it. Okay, so part C, add the result to both sides. So I have to also put it on this side. If I add something to one side of an equation, I have to add it to the other side. All right, so let's simplify this now. I've got x squared plus 8x plus, okay, 8 divided by 2 is 4, and 4 squared is 16. Okay, now it says factor the left side as a perfect square. All right, so we have this trinomial right here, and it is, so we think about this, what are the factors of 16 that add to 8 that has to be the same number, right? Because 16 is a perfect square. So it's 4. So this would be, I'm going to write an intermediary step here so we can see it. This would be the same as x plus 4 times x plus 4. If you FOIL this, you get the same trinomial. And then over here on the right, I have 1, right? 16 minus 15. But I want to write it as a perfect square binomial. So really what we want to say is x plus 4 squared equals 1. Okay, now remember what we're trying to do. We're trying to get x by itself, right? We're solving for x. Now we're going to take the square root of both sides. We're using the square root property now. And we're going to get x plus 4 equals, now what's the square root of 1? Well, it's 1, but it could be positive or negative 1. All right, now last step, we're going to subtract 4 to both sides. And I need more room. Scroll down a little bit. So now our answer is x equals negative 4 plus 1, or x equals negative 4 minus 1. So our solution is negative 3 or negative 5. Now, problem I gave you here in this example is easily factorable. I hope you see this, right? And we could have done another method, but I wanted to give you one that worked out a little bit more easily. I hope you see that this is just a simple, what are the factors of 15 that add to 8? Well, it's 5 and 3, right? And then when we solve here, we're going to get a negative 5 would make this 0, and a negative 3 would make this 0. And then so the That just kind of checks our solution. Okay. Quadratic formula. So if we were to do the complete the square method just on the standard form of the equation right here, right? We would have to divide out a here because we don't want anything in the but 1 as a leading coefficient. We get our c term, we would subtract it to the other side. We'd take half of the b term and square it. Okay, we would get the quadratic formula right here. So the quadratic formula is really useful when we have a quadratic that is not factorable. And complete the square is useful, but the quadratic formula is a simpler, more straightforward way for solving quadratics. And if we get nice rational, or we get real numbers, that's great, but it'll also work when we get complex. Okay, so here's the quadratic formula. And I recommend you guys want to memorize this in the long run. So write it a lot so that when you need to know it, you'll eventually memorize it. So a in this case is 1. That's our leading coefficient. B is 5, coefficient in front of the x term. And c is our constant term, which is 1. So we are going to substitute, and I recommend using parentheses anytime we substitute. This helps us keep our negatives straight. 5 squared minus 4 times 1 times 1 all over 2 times 1. Okay, so I'm going to remove the parentheses here. Got to do everything inside this. So this radical right here, this part right here, the b squared minus 4ac, we're going to see that later. That's called the discriminant. Okay, so we have minus 4 there, all over 2. So x equals negative 5 plus or minus square root of 21 all over 2. And we can leave our answer just like that. Let's box it in. We would like to simplify the radical if we can, but 21 has no perfect square factors, so that's as far as we could take it. So I just want to point out here that we would get 2 solutions with this quadratic, right? And we can really see, if we look what's under the radical right here, we know as we're working the problem here how many solutions we're going to get, right? So if this were to cancel and give us 0 underneath here, we would only get 1 solution. It'd just be negative 5 over 2. If this side is larger negative than this, and we get a negative under the radical, that means we're going to have a complex solution, a 1 with an imaginary number. Let's try this one. Oh. All right. So A is 1, B is 1, and C is 2. You see what's going to happen underneath the radical here? What are we going to get there? Okay, 1 squared is 1, minus 4 times 1 times 2 is 8. Look at this. We get 1 minus 8. Negative 1 plus or minus negative 7 over 2. Someone's coming in.
Hey, John.
Hey.
Which teacher is next door to you? Is that Cooper or is
That's
that
Kelby.
Kelby. Do you know what the number? There's no number. Yours is 20. If you don't know the number, that's fine.
I think it might be 21.
Okay, cool.
That was Mr. Hale. Hi, Mr. Hale. So I took out negative 1. Square root of negative 1 is I. Remember that, right? So I is the square root of negative 1. So that just leaves us I root 7. And if we wanted to write this in standard form for a complex number, this would be negative 1/2 plus I root 7 over 2. And you guys see, we have a complex solution here. We have an imaginary here. So this is not a real solution, but we can still show it as a complex solution. Okay, so the last thing that I want to talk about here, we have one more example here, but I have to do talk about a new term and its characteristics, is the discriminant. So the b squared minus 4ac that we just talked about here in the quadratic, right, is this part right here. This part right here. Depending on what this value is going to tell us about our solutions. So this is called the discriminant. So it's an expression under the radical in the quadratic formula, b squared minus 4ac, and it'll tell us this right here, okay? If b squared minus 4a is 0, there's only one rational solution. Okay, it ends up being a double solution, but it's still only one solution. If b squared minus 4ac is greater than 0, and the number ends up being a perfect square, okay, 1, 4, 9, 16, 25, we have two rational solutions. Okay, if it is greater than 0, the discriminant is greater than 0, but it's not a perfect square, that means we're going to get two irrational solutions. Okay, we'll have the square root inside that doesn't simplify. Now, if the b squared minus 4ac is less than 0, that's just like the example that we just did, we're going to have two complex solutions. In other words, we have a real number, potentially and definitely an imaginary. Okay, so let's take a look at A. The question is, use the discriminant just to determine the nature of the solutions. We're not actually solving it here. So we know that A is 1, B is 4, and C is also 4. Our discriminant is b squared minus 4ac. All right, so we're just going to evaluate this. Put it in. 4 squared minus 4 times 1 times 4. And 4 squared minus 4 times 1, a is 1, and c is 4. 16. And then what does this get right here? Minus 16. That's 0. Okay, so what does that mean? Let's go look at the chart. What happens when the discriminant is 0? We have one rational solution. Okay, so we have one rational solution. All right, that one's done. Next one, let's identify A, B, and C. Notice here we are already in standard form. If we weren't, we would have to get it there. Okay, so we got b squared minus 4ac is the discriminant. And so we got 14 squared minus 4 times 8 times 3. Okay, so 14 squared is 196 minus, let's see here, 4 times 8, this is, let's see, 32. 4 times 8 is 32 times 3. 3 times 2 is 6. 3 times 3 is 9. 96, okay. 96. 196 minus 96 is 100. Okay, so 100 is a positive number, and it's a perfect square. Okay, so we're looking at this second row right here. This has 2 rational solutions. Remember, rational solutions don't have a radical in there. This is going to be able to be written as a fraction. That's what rational means. Okay, 2 rational solutions. Next one here. So b squared minus 4ac, negative 5 squared minus 3 times negative 2. So negative 5 squared is positive 25, and I have negative and negative there. It's going to be plus, what do we have? 12 times 2 is 24. 25 plus 24 is 49. 49, okay, so it's positive, but this is a perfect square. Square root of 49 is 7. So this is just like part B over here. It's also 2 rational solutions. Okay. So D, I wonder if we're going to get a complex here, right? Usually the textbook is going to give us a couple of different examples. Let's see what happens here. Do we get a negative for our discriminant? So I got 3 squared. Sorry, I'm clicking the wrong thing. 3 is, that's A. Let's fix that. Negative 10 squared minus 4, A is 3, B, C is 15. So negative 10 squared is 100 minus, okay, 4 times 3 is 25. 25 times 15 is 180. I get a negative 80 here. The discriminant is negative. Okay, so what does that mean? Okay, it's less than 0 right here. 2 complex solutions. So not a real solution. Okay. That's it, everybody. Gone through all the notes. We did using the square root property. We saw complete the square method. We saw how we use the quadratic formula and how we are able to use the discriminant part of the quadratic to determine the types of solutions that we're going to get. Hope that makes sense, and I'll check you later.